We're not going to do tons of notes. We'll see how it goes. We'll do most of the first page or maybe all of it if we can go through it quick enough. Right? So now, we just did a quiz. Some of you did fabulous. Some of you guys, this highlights that, hey, we need to do a little bit more work. This is a harder chapter. There's a lot more things you need to memorize. This stuff is not as intuitive as the exponent law. The exponent laws are a little bit easier to memorize. Oh, we add here, we divide. But a lot more things to remember with a mixed fraction, an improper fraction. How do you do decimals? So you need to stay on top of those basic things because we use those all the way throughout the chapter. Now, today's lesson is being able to look at two fractions and be able to tell me which one's the bigger one of the two. I have two fractions, which one's the bigger one, which is the smaller one. Now there's a couple of techniques. If you were in my grade 7 class and we did this kind of question, and what we would do is just convert both numbers to decimals and compare which one's bigger or smaller. Easy peasy. You guys can, most of you guys got all that questions right when we did the quiz, converting numbers to decimals. Right? So that's method 1. Right? Convert numbers to decimals. Express both, oh no, that says method 2 here. Convert both numbers to decimals. Right? Then we compare the decimals. So it's easy to tell which decimal is bigger than the other one. Right? But that's not the method that we're going to spend a lot of time today on talking about. Right? That is a technique for grade 7, and which is still valid. Right? If you get stuck and you can't remember the technique that Mr. Dhaliwal was talking about next, go back and use it. But I want to teach you different skills. Right? So the other method is, hey, these are hard to compare. Just by guess, looking at these two numbers here, who thinks, by show of hands, 7 over 6 is bigger? No hands up. Who thinks 11 over 6 is bigger? Right? Just got to pull. Nobody's voting. Let's try again. 11 over 6 is bigger?
11 over 9.
Oh, sorry, 11 over 9. Sorry, 11 over 9. Who thinks 11 over 9 is bigger? All right, we're just going with your gut instinct. And who thinks 11 or 7 over 6 is bigger? All right, a couple people. It's kind of split. A lot of uncertainty. It's hard to tell. So what we use is common denominators. And we spent some time last day talking about common denominators. Right? So we make fractions with common denominators. Right? So you go, we have 6 and 9 sitting here. Both the denominators are different, so it's hard to compare. So we go, what number can both 6 and 9 be turned into? Right? Does anybody see that? Samira?
18.
18 works. Now, if you're not sure how we got to 18, remember you can use your multiplication chart. We have our two denominators. Erase this stuff here. Right? We have 6 here and 18, or 6 and 9 here. We look across both and you find the number that's the same. And 18 is both in both things. So 18, oops, let's do a highlighter. 18 here works, and here. But 36 also works, and lots of other ones work. Right? Doesn't matter, as long as you make the bottoms the same. We pick the numbers that are smaller, because it makes life a little bit easier. So for the 6 one, we're going to have times top and bottom by 3, and for the 9, we're going to have times top and bottom by 2 to make the bottoms the same. So we look at this, and you go, okay, let's go back here. And, right, so we're going to have to multiply this one by 3 to turn it to 18. And I have to multiply this one by 2 to turn that into 18. Right? 3 here, 2 there, and we write out the new fraction. All right. So 6 times 3 is 18. Then we have 7 times 3 is 21. And the other one is 2 times 11 is 22, and 9 times 2 is 18. Right? So what this does is gives us two fractions where the denominators are the same. Now we look at it. What's bigger, the 21 or the 22? Which one's bigger? The left one or the right one? The right one. 22 is bigger than 21. Right? We have 22 out of 18 and 21 out of 18. So 22 is the bigger one, right? So it says circle the bigger one, right? So we're gonna go here and we're gonna circle this or square it or whatever you want to do. And but you should do it to the original question, all right? 11 over 9, right? So make the bottoms the same. So we can compare the tops, right? So this. Now we're going to go fill in the notes so you can look at it backwards and figure it all out. Right? So this finding the common denominator is called, the math phrase for that's called LCM. Find the lowest common multiple. That's what that LCM stands for. Right? We looked at the multiples of 6. We looked at the multiples of 9, and we found that 18 was the lowest one that was common, right? That's what that phrase means, right? Lots more of that phrase gets used next year. So we talked about this. We didn't write it down. The lowest common multiple between 6 and 9 was the number 18. All right. So then we just rewrite our fractions and we compare. Okay? And we found out that 22 is bigger than 21. Easily done. Nicely done. Okay. Now if I asked you to kind of switch this up, instead of saying circle, I asked you to use the inequalities, the alligator mouth, right? Would the alligator mouth open to the left or would it open to the right? Right? Remember, the mouth opens up to the big one. So I can say circle the big one, or I can say write the inequality. So this side is bigger than this side. So the same question, slightly different. Add and make it a little bit more difficult by using the word inequalities. Right, so that's what we're going to do here. Instead of circling the bigger one, we're going to use these symbols here. So we have 3 and a 5. What is our common denominator? Samira? 15. So we're going to make both of them out of 15. So we're going to multiply 5 here, because that turns 3 into 15. Top and bottom. So we have 10 over 15. And this one, we multiply by 3. Top and bottom. 9 over 15. Right? Which one's bigger? Left one or the right one? Samira? Left one. 10 is bigger than 9. So the mouth opens up to the bigger one. There we go. All right. Next one. We have 12 over 8 and 2 over 4. Which one's our common denominator between 8 and 4? Samira?
16.
16. Does anybody see a different one? 8 as well. Right? So I'll go with 16 because Samira said it first, right? So to turn this into 16, we times top and bottom by 2, right? And turn this into 16, we have to times it by 4, right? So it doesn't matter which denominator we have. We tried to do the smaller one because the calculations are easier, smaller numbers, but it still works out. 12 times 2 is 24. 8 times 2 is 16. On the other side, 2 times 4 is 8, and 4 times 4 is 16. So bottoms are the same. Now all we have to do is compare the tops and the bottoms. All right? So what's bigger, 24 or 8? It's pretty straightforward, that one, right? So 24 is bigger than 8, so the mouth opens up this way. All right? Okay. And I think, should we do one more? Those should be, I want to see how much time we have. Okay. Let's skip this and go over here. All right. So once again, we want to compare which one is bigger, but not use any calculations. We use some, like I said, hey, next year you're going to have some questions that maybe you can't use a calculator for. And there's other strategies, right, that we can use. So if I have these two questions without doing any calculations, can somebody tell me which one's better, the left one or the right one? Can you tell by looking at it? Samira, why?
Because the other one's a negative.
Yeah. This one's positive. This one's negative. Right? So that's one easy thing you can check for. Positives are always bigger than negatives. So that's one thing you can check for. Positive versus negative. Right? Check. Positive versus negative. Let's look at another one. All right. Gauge, which one's bigger? The left. Do people agree with Gauge? He says the left one's bigger. Well, sorry, Gauge, what's your reasoning why is the left one bigger? It's more positive? Ooh, I like that idea. But I like how you're thinking, but your rationale is wrong. All right?
I hate it.
Okay, so this one has two negative signs on it, right? We're dividing. When you have two negatives, does that number become a negative or a positive? Positive. So when you're dealing with fractions, clean up multiple negative signs. So now we have a negative sign here and a positive sign here. So now the right one is bigger, right? So clean up multiple negatives. That's a shorthand for negative. Dash with a VE. You're going to learn that in science when you start talking about electricity. So you don't have to write the whole word up. Come on, Owen. Focus. Okay. Let's see. And how many more do we have here? I think I'm going to stop right there. I'm going to hand back